All right, and we're back, everybody. So welcome back. Today we're going to do section 5, day uno. That's day one. Spanish speaking time. Day ein. Day ein. Oh, not ein. It's just ein? Yeah. Not ein? Ein. It could be either. Good? Yeah. Or can you say yeah? You add the X. No, it didn't say. I would say 14 is. Yeah, 14. All right. So, take a look here. We got section 5.5. Now, understand, section 5.5 is the last section out of the first half of chapter 5 that we will do. Okay? This is the first half of chapter 5. This is the last section of the first half of chapter 5. That means we're going to have a test on Friday over the first half of chapter 5. Okay? We're going to do 5.5 day 1 today, 5.5 day 2 tomorrow, practice test work day on Wednesday, go over the practice test on Thursday, test over sections 5.1 to 5.5 on Friday. Okay? Now, in my opinion, section 5.5 is probably the most difficult section out of these first 5 sections. And the reason being is because direct variations are a unique type of linear equation. It's a unique type of linear equation. Only certain things work for direct variations. And let me show you what I mean here. This is an example of a direct variation. This is an example of a direct variation. Okay? A recipe for paella. Paella is a Spanish meal served in a big pot, a lot of seafood in it and stuff. A recipe for paella calls for 1 cup of rice to make 5 servings. In other words, a chef needs to add 1 cup of rice for every 5 servings that they are going to, give out. Okay? So take a look at my table there. Doesn't matter the context of this. What do you see about my table? What's the equation that I could make from my table? Y equals what? Carson? 5 what? Y equals 5. 5. What am I doing from X to Y? Right, but what's the operation? There we go. Y is equal to 5 times X, right? Y is equal to 5 times X. I take the X value, I multiply it by a certain amount, and that's my Y value. Ladies and gentlemen, this is an example of a direct variation. The equation Y equals 5X describes this relationship. In this relationship, we can say this: the number of servings varies directly with the number of cups of rice. Okay? Why? Because all I do, the only operation that I do to get X to Y is multiplication. That's it. No addition, no subtraction, just multiplication. Now, it could be multiplication by a fraction, which would mean division, but it's still multiplication. I only do multiplication. Y equals a number times X. That is what's called a direct variation. A direct variation is a unique type of linear relationship. It's a special type of linear relationship. All direct variations are straight lines. Not all straight lines are direct variations. Right? What happens if it's got a y-intercept? I must have added or subtracted something to it. Therefore, it's no longer a direct variation. But a direct variation is a special type of linear relationship that can be written in the form y equals kx, where k is just any number. It's called a constant. K is just any number. And it has a unique name. It's called the constant of variation. The constant of variation. That's what our k value is defined to be. So let's take a look here. Tell whether this is a direct variation. If so, let's identify the constant of variation. Liam, eyes open. If you need to stand up, go stand by Hannah. All right, here we go. Y is equal to 3 times X. Is that a direct variation? Yes. Is it in the form Y equals number X? Yes. Y equals K times X. y equals k times x. So what's my k value in this case? 3. My k value is 3. So we would say, yes, it is a direct variation, and the k value is 3. Is this a direct variation? Well, a direct variation is in the form y equals, right? It looks very similar to slope-intercept form, but not exactly, right? Because there's no addition or subtraction. So I've got to get it into y equals. How do I get y alone on the left side? I subtract 3x from both sides. So that will get me y equals negative 3x, and I'm going to put the x first, and then a positive 8. Negative 3x plus 8. Ladies and gentlemen, do you see how there is a plus a number? Then this is not a direct variation. Not a direct variation. Not a DV. It's not a direct variation. Y does not vary directly with x. Let's check another one. At first, I'm thinking, ooh, I see addition and subtraction. This is not a direct variation. But let's cool our jets a little bit. Let's actually solve it for y. What would be the first step to solve for y? Will?
Add 4x to the other side.
Good. And add 4x to both sides. And that will get me a 3y is equal to 4x plus 0. Do I really need to add on the plus 0? No. What finishes this off? To solve for y, to get y completely alone, what finishes this off? Divide by 3. Okay, so y is equal to 4/3 x. Is that a direct variation? Yes. It is a direct variation. It is in that form, y equals a number times x. So what's the constant of variation? What's the k value? 4/3. Questions about that? Okay, let's do another one. Is y alone on the left side? How do I make it? How do I make that happen? Subtract what? No. I don't want to move y. Liam? No. Don't add anything to that. Good. Subtract 2x over to the left side. Or sorry, over to the right side. So leaving me with a y is equal to negative 2x and then a positive 10. Is that a direct variation? No. This is not a direct variation. This plus 10 knocks it out. Not a direct variation. Why don't you guys try this one on your own? See if you can figure out is that a direct variation. Get y alone. Get y completely alone. And then see if it's just a y equals a number times x. Okay, what's the first step to getting y alone? Carson? Good. So that gets me 5y is equal to 3x. Carson, what do I do next? So y is equal to 3/5 x. Is this a direct variation? Yes. This is a direct variation. It is in that form y equals kx. So we can say yes, and the k value would be 3/5. Okay, so right now we don't even know what a direct variation looks like. All we know is, can we identify what it is, or if it is one, excuse me, if it is one. And yes, we can, based on the equation, we have seen, oh yes, we can identify what a direct variation is based on the given equation. So let's kind of analyze this a little bit more. What happens if we solve for k? What happens if we solve for k? What happens if I want to get k completely alone? What operation would get k alone? Tavea? I would divide by x over to the other side, right? I would divide by x over to the other side, and this is what I would get. K is equal to y divided by x. Notice there's a blank space underneath it, and I should write that down underneath it. Y equals kx. I would divide both sides by x. It would cancel out on the right side. So y would be equal to, or sorry, k would be equal to y divided by x. That's interesting. It's a ratio of y divided by x. What is another ratio of y divided by x? Oh, we just spent the last 2 sections talking about it. Slope. Oh, so the k value is actually slope? Yes. Okay, the k, that's why it's important. The k value is actually the slope of the line. And the direct variation of the ratio y over x is equal to the constant of variation. Another way to identify a direct variation is to check whether y over x is the same. What are we checking here? We're really checking if this thing has a constant slope. So let's check y divided by x. Let's find y divided by x for each of these pieces. I'll add another little row down there. Let's check y divided by x. What is 6 divided by 2? 3. What is 12 divided by 4? 3. What is 18 divided by 6? 3. Is this a direct variation? Yes. I didn't ask you whether this was linear, right? Please understand the difference between what we were doing last week and what we were doing this week. I'm telling you that it's linear. I'm just seeing, okay, is the linear relationship a direct variation? If it's a direct variation, y over x should be constant throughout. Not all lines have this. Only direct variations have this. So we would say, yes, it is a dv, direct variation, and the k value would be 3. Moreover, if the k value is 3, isn't y equals 3x my equation? It didn't really ask me for that. But if the k value is 3, my equation would be y is equal to 3 times x. If you take x times 3, do you get all the y values? Yep. Take a look at the next one there. Add on a row, see if this is direct variation. Let's take y over x for each one. What's negative 2 divided by 1? Negative 2. What's 0 divided by 3? What's 4 divided by 7? Ooh, 4. Is that a direct variation? No. This is not a dv. This is not saying that this is not linear, because guess what? Well, I guess it's not linear either. But this is not saying that it's not linear. All I'm saying is this is not a direct variation. Okay, this is not a direct variation. And the reason, it says to explain, the reason I would say for my explanation is because y over x is not constant. All right, now this is where it starts to get a little fun. The value of y varies directly with x, and y is 3 when x is 9. Find y when x is 21. Ooh. So I'm telling you that I know that this is a direct variation. Please pay attention to these problems. In my opinion, these ones are the most difficult ones that are going to be on the test. The value of y varies directly with x. That piece right there tells me this is a direct variation. I know eventually my equation is going to look like this. Go ahead and write that down. Y equals kx. We learned from the last part of my front page, what's k equal to again? Y over x. It's the slope, right? Y over x. K is equal to y over x. So to finish off my equation, to get my k value and plug it back in, I need to take the y value divided by the x value. Well, which one? This piece right here. Y is 3 when x is 9. I basically gave you an ordered pair. 9, 3. Okay, well that's 3 over 9. What does 3 over 9 reduce down into? 1/3. So my K value is 1/3. Oh, I should have showed you. Does it have there on it? On the test, I'm actually going to show you exactly what the blanks are going to look like. If you want to write those in for yourself, that might be a good idea. I will ask you, what is the K value? What is the equation? And what is the answer? Okay, we just showed the work for finding the K value. So on the top line, you would write 1/3. Now we are ready to make our equation. If the K value is 1/3, then my equation is, and again, every equation should have a y and an x. My equation should be y is equal to 1/3 x. That's your equation. I take x values, I multiply them by 1/3, it spits out my y value. Okay, so to answer the problem, I say, find y when x is 21. Okay, so I take my equation, y is equal to 1/3 x, and I plug in 21. What's 1/3 of 21? 7. I want everybody to try part B on your own. Okay, to find my K value, I take y divided by x. 20 divided by -8. What does that reduce down into? What does that reduce down into? Trip? Oh, you got the other way around. -5 over, oh, sorry, I did x over y. I'm so sorry. Whoops. -8 over 20. You're right, -2/5. Flipped around. So that's my K value. So y is equal to -2/5 x. I'm going to be picky about that equation. You don't put a y, I take off points. You don't put an x, I take off points. You write y equals kx, I take off all points. It should include y equals the K value that you've already found, -2/5, times x. So my answer is going to be y is equal to -2/5 times, well, x is -4. All right, well, I've got -2/5 times -4. My answer is 1.6 if I wanted to write it as a fraction, 8/5. Either way would be fine. So that's a direct variation. That's a direct variation where I don't have any pluses or minuses on it. Okay, if y is equal to a number times x. Tomorrow we'll talk a little bit more on the word problem side of direct variation. So long, everybody playing along at home.